Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back to doing some upgrades to our R8, and I'm going to separate these videos into shorter segments of what I call kind of test segments. And what I mean by that is whenever I'm working on something like this and we're either building or modifying or upgrading some audio gear, I always like to do it in small sections and then test as I go along. And if I'm building one, that means like we build power supply, then we power the amp up and test it, and then we build the output section and then we test it, and so on, so that if there is a problem, we're not dealing with a where's the problem at, because we've done so much at once. So in this segment, we're going to be replacing these two big power caps, and then we're going to be doing the resistors on the output tubes. And then we'll go put this thing back in the system, listen to it, and make sure that everything's still working before we move on to the next section, which will likely be this little section over here under the power transformer with the resistors and capacitors there. So it also keeps the videos shorter, and then you can do these upgrades kind of in small sections and also be able to see what difference each one makes, instead of doing it all at once and going, well, did that really do anything, or which one made the big change? Because I don't want to do like all these resistors and the coupling caps at the same time, and then the sound massively changes and we're like, which one did what? And then we don't know if we do something that actually makes it sound worse, we don't know how to backtrack because we've done too many things at once. So anyway, that's the way we're going to proceed through this amp. First, we're going to be doing what I call upgrades, which is just replacing components, passives like these resistors, these electrolytic caps, and then finally we're going to replace the coupling caps and see what change that makes. So let's get busy. Okay, first thing we're going to do is replace this big filter cap in the power supply. There's two of them, and I'm going to show you doing one. The other one's the identical procedure. And the reason we're replacing these is they're rated at 450 volts, and I saw 480 volts on power up. And while there is a percentage of going over for a short period of time that capacitors are designed to deal with, it's still not ideal. And given we're replacing so many other capacitors in this amplifier, I felt that replacing these was kind of a no-brainer. So I found some Cornell Doobler caps. As you can see, same diameter. It's about 5 millimeters longer. There's plenty of room here at the back of the cap for a little additional length, so it's not going to pose any problems. So let's go ahead and get these things replaced. I would use a small pair of needle nose pliers to deal with the wires. You also need a soldering iron, and you want the iron set fairly hot. And one of the reasons for that, while this may sound counterintuitive, with a hot iron you're spending less time with the heat on the joint so that there's less heat soaking into the device you're replacing or installing. And so having a colder iron, then you would have to hold the soldering iron on the joint for a longer period of time to bring it up to the temperature the solder will melt. And in doing so, that extra time allows the heat to radiate into the capacitor. So I've got my Hakko soldering station set for 750 degrees Fahrenheit, and we want to get the tip nice and clean. Come in here and freshly tin the tip so that we know it's nice and clean. Shake off the excess. And it doesn't matter which one of these you do first. We're going to do the positive. Heat this up, pull the wires free. Then come over here and do the same thing on the negative. Heat the joint up and pull the wires free. Then we come in with a screwdriver and remove this screw. Bring the bracket up and remove the capacitor. You see they've put a little bit of tape on here to protect the capacitor in this clamp, and we're going to install the same tape on the new capacitor. So here we go with the capacitor taped up. We've moved it slightly in this direction so that we kind of split the difference between the location of the old one and the new one as far as this end versus this end. They kind of split the difference in the extra length. So we've moved it a couple of millimeters towards the front of the amp, but the position of it really isn't that critical. And we're going to go ahead and snug this clamp down. Now understand that a electrolytic capacitor is highly polarity sensitive. If you install this backwards, as soon as you turn it on, it's going to blow up. And so this is one of those things, just I would hope people would know that the black wire goes to the negative, which is what this stripe is, and the positive goes to this other terminal. These were meant as snap-in capacitors, and we're soldering them in. So I'm going to straighten these leads out just a little bit by squeezing them in some pliers, just to give us a little more kind of purchase to solder this on there. And then we're going to come in here and heat up the wire and that terminal at the same time. Flow some solder into that joint. And there's the positive soldered back on. Give it a little wiggle, so make sure we get a really good connection. And we're going to come over here and do the same on this negative one. Actually, I'm going to bend this a little bit down like that, so we get a nice parallel connection there for this solder joint. And then come in here and heat this up. Flow the solder in. And then when we're done, come in, give the wires a good wiggle. Make sure we got a good connection. And we're done. So let me go over, jump over here and do the one on the other side. And then we'll get to work on doing the work with replacing the resistors. Okay, so the next thing we're going to do is replace these resistors around the output tubes. And there's 3 resistors. There's a 10 ohm, a 1K, and a 39K. And here are the 10K resistors I'm using. They are 0.5% precision resistors because we want to make sure that these 10 ohm resistors here are the same on each channel and that they're as close to 10 ohms as possible, because this resistor is being used as a shunt for the meter. This yellow wire here goes to the meter, and this is the ground. So the meter is measuring the voltage drop across this resistor to determine how much current is running through the tube. So we already did this channel earlier because this was the resistor that got roasted in this amp when it was brought to me. So we're going to do this channel today. Let's go ahead and get this one front and center. We've got our soldering iron warmed up, and I always clean the tip on the little brush and then come in and put some fresh solder on it to tin the tip to get a nice clean soldering surface on the iron. Heat that up, pull that resistor out, And then pull that resistor off. And then go ahead and remove these two resistors. Now the nice thing is we do have other tubes we can look at to make sure that we're soldering these resistors into the right location. And since we've already done this one, we know exactly where we're going to be putting them. So we come in here with our 10 ohm resistor first. We want to go ahead and kind of bend this thing up like somewhat to the shape of the other one. Except this one's going to be going in this direction. Bend that around. And then bend this down. And look about how long that one's going to be. Cut that off. Cut that off. Get our little needle nose pliers. Come in here and bend that end over like that. And then this resistor is going to get soldered in just like this. There's one end. And then let's go ahead and wrap that around there. Solder that end on. And get rid of the little blob there on the underside. There we go. So here's our 10 ohm cathode resistor in place. The next one we're going to put in is our little 39 ohm resistor. We come in and bend it over like that. It's going to go across there, just like that. We'll go ahead and attach this end. That. Then we'll come in here with our 1K resistor and do the same thing with it. And come in here and go ahead and bend that around so it comes through this hole like that. I'm going to go ahead and put a little blob of solder right here. Get that ready. And come in and solder this side of this resistor in. And then the last one will be solder the other side of this one in. Just like that. And we'll probably come back and add a little bit of solder right there. Just make sure we got a nice good connection there. And if you want, you can squeeze that together to neaten that up. And there we go. So again, this is the 1K resistor, this is the 39K, and this is the 10 ohm. And let me go ahead and do the other two output tubes, and then we'll be done with the first step in this little upgrade we're doing. Okay, so we got this first round of stuff done. Here's these two big capacitors we've replaced. Again, negative stripe, negative, positive, negative, positive. Got the 1K, 39K, 1K, 39K, 1K, 39K, 1K, 39K. There are 4 10 ohm resistors. One thing I'm going to do now is I'm going to go ahead and power the amp up. I'm going to hook it up to the system, speakers and everything, and make sure everything's working, and do like one step at a time in this update of these components to make sure that if I do end up with a problem, you don't want to replace everything all at once. Like if we come in here and replace all these resistors and all of these, and then got a whole bunch of resistors on this little section here with this voltage regulator and the preamp tubes and then the phase splitters. We got resistors all over this little area. We don't want to be going, what do we do wrong? Nothing works now. So if you test after each segment that you update with these higher quality resistors, then you know where the problem is if something does arise. Also, just double check that you got the right color resistors in that location and that the right color ones in this location, and make sure that you're putting all the correct resistors in the right places. And it's easy enough to do, especially if you orient the resistors in the same direction so that the color bands are going from the gold on one end to the colors on the other. It makes it easier to double check your work. So I'm going to go hook this thing up, go listen to it, make sure everything's good, and come back, and we're going to work on this section here in the power supply and replace all of these resistors and these 2 capacitors. Well, I went and listened to the amp, and everything was working just like it was before and seemed fine, and played around with just listening to it some more. And I do feel like there's some detail missing in this amp that I'm hoping is in the coupling caps. And my experience with listening to amps with just kind of run-of-the-mill film caps versus these nicer things like these Mundorf aluminum wall caps, I think that's what I'm hearing. These resistors did seem to clean it up a little bit, so I think I'm on the right path replacing these resistors. I also found at least 90% of the hum that I was experiencing. What I was hearing is when I would go to a channel that had the input jacks hooked to something, it was quiet at 0 volume. I could hear a little bit of hum when I had my ear right up to the speaker, and then when I'd go up to full volume, it would go away, which is kind of a perplexing thing. I didn't really understand why it was doing that, to be noisiest at the middle. And it still might be there a little bit, which it might have something to do with the way they have the volume control set up. But I got rid of at least 90% of that hum. I found this joint on this resistor had come loose, or was like a really loose solder joint. And I'm not sure if there was some kind of heat did this, because if we zoom in here, you can see this resistor has either gotten hot or something caused the outer part of it to crack. And this is the joint right here that had come loose. And I can't imagine that they've using solder that was so low temperature that it would melt. So I think that was just a bad solder joint in combination with the heat from the amp getting overvolted. It lost the connection on this side of this resistor. When I reflowed this solder joint, 90% of that hum's gone. It's just barely audible now. So, like I said, if you get 6 inches away from the speaker now, you can't even hear it. You've got to put your ear right up to the speaker. And so I know a lot of people are saying in the comments that theirs are dead quiet. I don't know if maybe theirs are all doing this half volume thing, and it's just so low that unless you just cram your ear up to the speaker, you don't hear it. Anyway, that's not a big deal, not a real concern if that never goes away. So the next thing I'm going to be doing is coming in here and replacing all these resistors here in the power supply, and then retesting the amp. So that may be in the next video. We'll see how things go. And let's wrap this up here. Well, I just got back from listening to the amp after this first little round of upgrades, and everything's working fine. Off camera, I checked the current running through the tubes with the meter centered, and just like I suspected, going with these high precision 10 ohm resistors, now the tubes measure almost exactly identical in their current readings going by the meter. So the resistors that come in the amp are obviously a little less precision than the ones that I put in as part of this upgrade, and I do think that is a good thing to do while you're working on this amp, to even out the current draw in the tubes, which is important on a push-pull amp. Also, the hum that I was hearing before, and I think some people probably misunderstood this. This isn't like a brrrr that you hear like at the seating position. This was like literally putting my ear like this, just right up against the speaker cone listening. And I still think there may be something going on with the potentiometer, maybe not being a super high quality one. Again, I'll have to do some disassembly work to look at it, because it's absolutely dead silent at 0 volume. It peaks out at the mid volume, and then at full volume it goes away again. And so that's telling me when we have the signal going through the potentiometer, or 1/2 on each side of the potentiometer to the wiper, that it's picking up some noise somewhere. And I'm not sure, again, what's going on. Could be a grounding issue with that board, could be some other grounding issue. I still want to address that in the modification part of the amp, but for this part, I'm trying to see what we can do by simply replacing some components that anyone should be able to do once you learn how to solder. And if you don't have a good soldering iron, this little Hakko, I love it. I mean, I've used all kinds of different soldering irons over the years, the little, standalone pencil kind, which will work, the little $15, $20 ones, but spent $100 on this kit. Comes with a cleaner, comes with a little sponge, it's got a really nice holder for the iron. The iron doesn't get hot, it's temperature regulated, you can set it for the temperature for the job at hand. It's also got a lot of power, which normally would be a problem with electronics if it wasn't temperature controlled. And the nice thing about having some extra power is if you're doing a larger component, like one of these bigger caps, you can set the temperature pretty high. Then when you get in here and start soldering on one of these bigger lugs, then you start using the wattage that this iron has versus a little tiny pencil that might not be able to heat the joint up, or it takes so long that it overheats the components. So I'll put this in a link in the description below. So I did a little more tube rolling, and I tried some of these KT88-Z Shuggy tubes that I've had for a long time and just sitting in my stash. And I think I like them just a little better than the Gold Lions. They seem a little smoother, and they don't make as much power. I did run the audio analyzer suite running these tubes, and the amp makes 40 watts instead of 45. And so I'm not sure exactly what's going on there. 40 watts is still a lot of power, and it really does have kind of a sweeter sound, but I need to do some more listening between the two, and it's kind of a moot point because these tubes are out of production. You're probably not going to be able to find a set of them, and I did find a set, and I'll link this below, where I buy these tubes and buy my tube rings and volume knobs and some other stuff. I've got no affiliation with that group. I don't get anything out of promoting that, and so use at your own discretion. I have bought a bunch of tubes from them. I've bought, some of those 300B-Z tubes. I've bought some 2A3 tubes. I've bought, anyway, a whole bunch of tubes and a whole bunch of those tube rings and knobs, and everything's high quality. It's quick shipping. It's free shipping. You sign up an account, you get another, I think it's 10% off, so it's worth doing that. Anyway, seems like a really good company. Never had any issues out of them, so I'll put that in the description. Anyway, I'm really happy with the way this thing's turning out. I'm really happy to found what was causing the majority of the louder hum. And I still haven't gone back and tested my phono stage to see if that weird ground loop thing was resolved by finding that bad solder joint on that one resistor. And I'm kind of waiting. I'm going to go ahead and replace all those resistors, because if there was a bad solder joint there and that one resistor looks so cooked, I don't want to base what I'm hearing out of this amplifier on possibly a bad resistor. So we'll save that for the next video. I do think we're already heading in a good direction. I also did A/B listen to this amp in my DIY 300B amp, which is kind of my reference amp. And this doesn't have quite the detail that my 300B amp has. And especially on the bass, it's kind of smearing some of the details in a grungy bass guitar kind of riff that I listen to judge the sound of amplifiers, which is a really hard thing for an amplifier to reproduce cleanly. And most amplifiers just kind of smear it into one bass note, but a good amp will reveal the kind of grunginess that's in it. And this is in Elton John, Madman Across the Water, which is a really great song for testing the audio qualities of an amplifier. A bad amp will also make Elton's voice sound kind of weird. His voice on that song is kind of balancing right on the edge of being shrill instead of sounding like a guy's voice. And if the amp isn't neutral, it can distort the tonality of his voice. So it's a really good song for testing audio gear with. So anyway, I think what I'm hearing is likely the coupling caps. And I'm excited to get to that point, but I don't want to jump ahead. I want to go ahead and get all these resistors and electrolytic caps replaced with some known high quality stuff. See what that does for the sound. Make sure that, all these solder joints have a really good connection, and that there's not some other thing, that maybe one of these electrolytic caps got damaged when that tube red plated. That's why I want to replace all this stuff first before I really make a judgment on what this amp sounds like. And then we can swap those coupling caps out and see what kind of improvement that makes as an upgrade. So I hope you're enjoying this series. I'm really enjoying working on this amp. I can't state again how really high quality this amp feels. It's just got a really beautiful finish. The chassis is so nice. I like the layout of the tubes. It's just a really nice piece. And for what they're charging for these amps, it's a bargain, even if it is a jumping off point into doing some upgrades and mods to it to turn it into something spectacular. So if you're enjoying this content, please subscribe. Thanks to all you new viewers. Like the video, and we'll see you real soon. Have a nice day.